Alright, in this video I want to explain the concept of a probability tree. And probability trees are just diagrams to help you compute probabilities of certain events happening. So let's look at a simple example here to try to illustrate this. And then maybe we can also do a slightly more complicated one. So, okay, suppose two balls are drawn in succession without replacement. So once we pull one out, we're not going to put it back in. And we're going to do this from a box that contains 3 black and 2 red balls. We want to know what's the probability of drawing a black ball on the second draw. Okay, so, well, different things can happen, right? You can when you pull out the first ball, you can either get a black one or a red one. And then on the second draw, you can again get a black one or a red one. So let's make a little tree diagram here. So again, what we're going to do is I'm going to label the outcomes that can happen. So I'm going to put a little B sub 1 to illustrate that we could get a black ball on the first draw, or we could get a red draw on the first draw, so a little R sub 1. And along the branches, I'm going to put the probabilities of that occurring. Well, let's see here. So to compute the probability of that happening, well, there's 1, 2, 3, 4, 5 balls total, so that's the denominator of my fraction. 1, 2, 3 of those are going to correspond to black ones, so that means we can get a black ball on the first draw with a probability of 3 out of 5, and likewise we would get a red ball with a probability of 2 out of 5. Okay, so that's what could happen on the first draw. Well, on our second draw, again, we could either get a black one on the second draw, or we could get a red one on the second draw. So I'm going to label those possibilities. And now we have to be a little careful because, again, we're doing this without replacement. So now, if we follow the top branch along, we're assuming that we've already got a black one on the first draw. So since we're doing this without replacement, one of the black ones is now gone. Okay, we got a black one the first time. So what would be the probability of getting a black ball on the second draw? Well, now there's only 4 balls total, 2 of which are black. Likewise, the probability of getting a red ball on the second draw. Again, assuming that we got a black one the first time, that's what this first branch is telling us. We're assuming we got a black one the first time. Well, the probability of getting a red ball on the second draw would be also 2 out of 4, because there's 2 red balls out of 4 total balls. All right, let's do this the bottom branch as well. So now we're assuming we got a red ball on the first draw. So now we have one less red one. Okay, so we want to know the probability of getting a black ball on the second draw. Well, there's again 1, 2, 3, 4 balls total, but 3 of those are going to correspond to black ones. So there's a 3 out of 4 probability, 3/4 probability of us getting a black ball on the second draw, and likewise there would be a 1 out of 4 probability, 1/4 probability of us getting a red ball on the second draw. So that's what our tree diagram is telling us here. If you think about the top branch, that's telling you the probability of getting a black one on the first draw and a black one on the second draw. This branch below it, that's telling you the probability, it's going to tell us the probability of getting a black ball on the first draw and a red ball on the second draw. If we follow the bottom branch and then we take the top branch, that's going to tell us the probability of getting a red one on the first draw and a black one on the second one. And likewise, the bottom branch is going to tell us the probability of getting a red one on the first draw and a red one on the second draw. Okay, so again, what we're really interested in, though, is figuring out the probability of getting a black ball on the second draw. Well, the top branch corresponds to getting a black ball on the second draw. And then also this third branch down corresponds to getting a black ball on the second draw. And recall, to compute these probabilities, we just simply, the idea is you multiply the probabilities along the branches. So again, to get a black ball on the second draw, assuming we got a black one on the first one here, it says that's going to happen with a probability of 3/5 multiplied by 2/4. Well, if we simplify that, that's going to give us, we could reduce, so that's going to be 3/5 multiplied by 1/2. I'm just reducing 2/4 to 1/2. And that's going to give us a probability of 3 out of 10. And then to get the probability of getting of having a red ball on the first one and a black one on the second, again, we just multiply the probabilities along the branches. So that's going to be 2/5 multiplied by 3/4. Well, we just multiply across the top. That's going to give us 6 over, whoops, I wrote 60. That's going to give us 6 over 20. Which again is just going to reduce to, if we divide the numerator and denominator by 2, that's going to give us a probability of 3 over 10. So in terms of the notation, we're trying to figure out, we want to calculate the probability of getting a black ball on the second draw. That's what we're ultimately interested in. Well, that can happen in 2 ways. Again, we can get a black one on the first one and a black one on the second one, or, which is going to correspond to addition, we can get a red one on the first one and a black one on the second one. But again, we now have those probabilities. We just computed those. So we said the probability of getting a black one on the first draw and a black one on the second draw, that's 3 over 10. And then the probability of getting a red one on the first draw and a black one on the second draw, that also turned out to be 3 out of 10. So if we add those together, we've got common denominators, so we can just add across the numerator. That's going to give us the fraction 6 over 10. We can divide the numerator by 2, the denominator by 2. That's going to reduce to 3/5, which is equal to 0.60. Or it tells us there's a 60% probability that we would get a black ball on the second draw, which intuitively, to me seems like it makes sense, right? Because at the beginning there's more black ones in there than red ones, so I would assume it to be over 50%, which is exactly what we found.